All right, so in our 3.2b video, we're going to go over the last solving method for finding the solutions of quadratic equations and functions. So we've already been over quadratic formula, we've been over factoring to solve, we've also been over using substitution with factoring to solve, and so today we're going to go over completing the square. That's our last method, and then we're also going to look at some word problems. When we get to the word problems, you can use whatever solving method best suits your preference. But I do want to make sure that you know on the exam you will be required to complete a problem using the different methods. So by substitution, by factoring, by quadratic formula, and also by completing the square. So make sure you do practice the required method when you're doing those specific homework assignments, okay? All right, so what completing the square does is that we're trying to come up with a perfect square trinomial. And a perfect square trinomial would be something like x squared plus 2x plus 1. This is a perfect square trinomial because if I were to do some product with this, here we would have a sum of 2 and a product of 1, right? So we need something that multiplies to 1, that combines to 2, which would be 1 and 1. And since our leading coefficient's 1, we could use the shortcut. So this factors into x plus 1 times x plus 1, which we can actually write this as x plus 1 quantity squared. This is what we want to create, okay? And the reason we use this completing the square method to create a perfect square trinomial like this is it comes in really handy when we get into putting equations into vertex form when we're graphing parabolas. It also comes in really handy when we are completing the square in order to put an equation of a circle into its standard form. Okay, so not maybe necessarily the solving method of choice that I would use, but there is a very specific use for knowing this way of solving. Okay, so completing the square, what we're going to do is we're going to make sure that the terms that have variables are on one side all by themselves. So like the x squared and the x term, we don't need the constant term, so we move it to the other side. Then we make sure that the coefficient is 1. The leading coefficient has to be 1. So if there's anything in front of that x squared, we have to divide it off of everything. Okay, then we get into the completing the square process, which I'll show you here in a minute. We're going to take half the x term coefficient, square it, and add it to both sides. And then from there, that should create a perfect square trinomial on one side of the equation, which we'll be able to then factor into this form. And then from there, we'll be able to solve using our principle of square roots. Okay, so let's just go ahead and jump into an example. First thing we want to do is make sure our constant's on the other side. We don't need it. So here our constant is 13. We're going to move it to the other side by subtracting. So I have x squared plus 6x is equal to negative 13. And then we make sure our leading coefficient is 1, which here it is 1. So that's perfect, right? So now that our leading coefficient is 1, we can go ahead and start the completing the square process. So when we complete the square, we're going to take half of the x term coefficient. So our coefficient here is a positive 6. So if I take half of positive 6, that gives me 3. And I'm going to go ahead and tell you this is going to be a shortcut. Using this number, we have a shortcut we can use. And I'll show you what that is at the end of the problem. But I want to make sure you know how to work it out without the shortcut in case you forget. Okay. So now that we took half the middle term, or half the x term's coefficient, we got 3, we're going to square that number and add it to both sides. So on the left-hand side, we have our x squared and our 6x, and now we're going to add in our 3 squared. On the right-hand side, we had a negative 13, and we're going to add in that 3 squared. Okay. So now that we've added in our little shortcut number here, now we just want to simplify both sides. So on this side, we end up with x squared plus 6x plus 9. On the other side, we get negative 13 plus 9. And then we simplify, right? So when we simplify this side, I want to be able to factor it. This should be a perfect square trinomial. So if I check it using my sum product chart, I need something that multiplies to 9 that combines to 6. and two numbers that multiply to 9 that combine to 6 would be a positive 3 and a positive 3. And because my leading coefficient is a 1, I can use the shortcut that tells me these are my factors. So I know this factors into x plus 3 times x plus 3. And I can write that as x plus 3 quantity squared, right? So my whole left-hand side becomes this perfect square factor, right? Okay, so now we need to simplify on this side. We have negative 13 plus 9, which leaves us with a negative 4. And then we can go ahead and solve this now by extracting square roots, right? So if I take the square root of both sides, the square root of x plus 3 squared is going to cancel. And then don't forget your plus or minus, the square root of negative 4. So we end up with x plus 3 is equal to, now on this side, remember the negative under a square root, that comes out as an I. And then the square root of 4 just becomes 2. So this gives me plus or minus 2i. And then I move my 3 to the other side by subtracting. Since I cannot simplify, right, I can't combine the negative 3 and the 2 because the 2 has an I on it, we're just going to leave it as negative 3 plus or minus 2i. And in my math lab, they'll just give you a big box to enter your answer. So you'll have to do negative 3 plus 2i, and then a comma, and then negative 3 minus 2i as your two solutions. Okay. All right. So this is completing the square. Get rid of the constant term by moving it to the other side. Divide off any leading coefficient that you have, which in this case was already a 1, so we don't have to worry about that. And then we do completing the square. So we take half the middle term coefficient. Whatever that number is, we square it and we add it to both sides. On the right-hand side, we should be able to simplify down to a number. On the left-hand side, this should always factor into a perfect square trinomial. Okay? And then once we have it as a quantity squared equals a number, then we just solve it using the square root method. Okay? All right, so here's where the shortcut comes in. Sometimes when we take half of our middle term, it doesn't come out pretty. This one came out really pretty, right? Half of 6 is 3. Yay! But what if our middle number had been like 19? If we take half of 19, that gives us a decimal or a fraction. And then when we square 19 halves, or, you know, whatever, 9.5, that's going to be really hard to do sum product with, right? Because we're going to have a fraction constant term or a decimal constant term. So we have a little shortcut that helps us bypass all of this and go straight to here. So what the shortcut method is that when we take half the middle term and we get 3, we do need to take that 3 and square it and add it to both sides, for sure. Do not forget that. But the cool thing is this left-hand side, instead of doing the whole sum product thing, whatever we get as this shortcut number right here, that will always end up being the number inside our squared quantity. Always, always, always. So as soon as, you don't have to write this, but as soon as you get to this step where you say, okay, x squared plus 6x plus 3 squared is equal to negative 13 plus 3 squared, once you get to this step, I'm fine with you just saying that we have a shortcut for this side. And the shortcut says that it will always factor in our squared quantity to be our variable, which is x, and our shortcut value, which in this case was a positive 3. So this just factors into x plus 3, and then we simplify that side, right? So instead of having to multiply out the 3 squared and do some product and write it factored and then write it as a squared quantity, I'm fine with you going straight from this point down to knowing that that factors into x plus 3. Okay, so let's do a couple more just so that you can kind of get a feel for using that shortcut. Okay, so let's look at a couple more examples. First thing I need to do is make sure that all of my x terms are on one side and my constant terms on the other. So that means this negative 1 I need to move to the right side, and my 3x I need to move over to the left side. Okay, so I already have my 2x squared over there. If I move my 3x to the left side, the way that I move my positive 3x is by subtracting it. So it becomes negative 3x. And then that's going to be equal to my constant term, right? My constant term is a negative 1, but if I move it to the other side, it becomes a positive 1. Okay, so I have all my x terms on one side, my constant term on the other, but my leading coefficient must be 1. Must be 1. Okay, I cannot do completing the square. It will never turn out to be a perfect square trinomial unless the leading coefficient is a 1. So my next step is to get rid of that 2. So I'm going to divide every single term by 2. So I get x squared minus 3/2 x is equal to 1/2. Okay. All right, so now I have my x's on the same side, I have my constant on the other side, my leading coefficient is 1, now I can do my completing the square. So completing the square says I look at my x term coefficient, which in this case is negative 3/2, and I want to take half of that. So if I do half of negative 3/2, right, half of means half times, so half of negative 3/2, that gives me negative 3/4. So this number right here, this is going to be my shortcut number. Okay, so first of all, I need to square that number and add it to both sides. So on the left-hand side, I had an x squared, I had a negative 3/2 x, and now I'm adding in my shortcut number, which is negative 3/4 squared. On the right-hand side, I had the 1/2, and I'm adding in my shortcut number squared, so negative 3/4 squared. Okay, I do want you to write out this step even if you use the shortcut, because if we just use the shortcut on this side, everybody always forgets to square and add this to the other side. Okay, now on this side, instead of multiplying this out and figuring out what the sum product is with fractions, I'm going to go ahead and just use my shortcut. My shortcut says that this should factor into a perfect squared quantity, and the squared quantity that it will factor into is always my variable and then my shortcut number. So notice my shortcut number is negative 3/4. So this factors into x minus 3/4 quantity squared. And then on this side, I just have to work out what this ends up being so that I get a nice pretty number here, right? So I have 1/2 plus, when I square negative 3/4, that gives me 9/16. And then in order to add these, I need a common denominator, which would be 16, right? This one already is written as 9/16. This one, to write it with a denominator of 16, I would have to multiply on top and bottom by 8. So that gives me 8/16 plus 9/16 is going to give me 17/16, right? So I have the quantity x minus 3/4 squared is equal to 17/16. And now I have it written as a perfect squared quantity is equal to a number. So now I can solve by taking the square root. So I'm going to go ahead and take the square root of my squared number. Don't forget your plus or minus. So my square and my square root cancel. So I have x minus 3/4 is equal to plus or minus. Now here, square root of 17 does not simplify, right? That's a prime number that's not a perfect square. 16 does simplify though. So I am going to simplify the bottom. So I'll just leave the 17 under the square root, but then the 16 I'm going to simplify to 4. Okay? And then the last thing I have to do is move my 3/4 over, and I do that by adding 3/4. So I end up with x is equal to 3/4 plus or minus the square root of 17 over 4. Again, my math lab may have you separate that and write it as 2 separate answers, but I'm fine on an exam or on a worksheet with you putting the plus or minus. So quick recap, okay, and then I'm going to do one more and then I'll have you all try some. So we get our constant term on one side so that just our x terms are on the other. Make sure our leading coefficient is a 1 by dividing off anything that happens to be in front of it. Once I just have an x squared and an x term on one side, then I can go ahead and do my completing the square, which is to take half the middle term. And when I take half the middle term, I get negative 3/4. That's my shortcut number. That's the number that's going to end up in my squared quantity, right? So I take that shortcut number and I square it and I add it to both sides. On this side, we know that this is going to end up factoring down into my nice perfect squared quantity, which is my variable and my shortcut number, so x minus 3/4 squared. On the other side, I have to go ahead and square this out and combine to get a number, okay? And then I solve by taking the square root of both sides. So let's look at one more, and then I'll have y'all try one, okay? So first things first, we move our constant term to the other side. So if I move my positive 3 over, I do that by subtracting. So I get 3t squared plus 8t is equal to negative 3. And then remember, our leading coefficient must be 1. Okay, so in order to get my t squared term to just have a leading coefficient of 1, I need to divide off that 3. But if I divide it off that term, I have to divide it off of every single term in this equation. Okay, so that leaves me with t squared plus 8/3 t is equal to negative 1. And now that I have just my t squared and my t term on the same side, I can go ahead and start the completing the square process. So I take my middle term coefficient, or my t coefficient in this case, right? And I'm going to take half of it. So I'm taking half of 8/3. So half of 8/3 gives me 8/6. And then I'm going to go ahead and reduce that down to down to 4/3. So this is my shortcut number. Okay. Now before I can do my shortcut, I have to square that number and add it to both sides. So on the left-hand side, I have t squared plus 8/3 t plus, I'm adding in my shortcut number squared, so 4/3 squared. On the right-hand side, I have the negative 1 that was there, and I'm adding in my shortcut number squared, so 4/3 squared. Okay. So now this should create a perfect square trinomial. Instead of multiplying it out and figuring out some product with fractions, we're going to go ahead and just use the shortcut for this side. Okay. And the shortcut says that this whole mess should factor into a perfect squared quantity that involves my variable, which in this case is a t, and my shortcut number, which is a positive 4/3, so plus 4/3. Okay, and then on the right hand side, I just need to go ahead and simplify. So notice, I know this is going to stay a fraction, so I'm going to go ahead and write my negative 1 as a fraction. I'm going to write this as negative 1 over 1. When I square 4/3, that gives me 16/9. So I'm going to need a common denominator, which will be 9, right? So this first fraction, I'm going to multiply on top and bottom by 9. So that gives me negative 9/9 plus 16/9. And then I can go ahead and simplify. So t plus 4/3 quantity squared is equal to negative 9 and 16 leaves me with positive 7/9. And now that I have a squared quantity is equal to a number, I can get rid of that square by taking the square root. So I take the square root of t plus 4/3 quantity squared, and that equals plus or minus the square root of 7/9. 7/9 is not a perfect square, but the 9 is. So I can simplify the denominator and just leave the 7 with a radical. So this gives me t plus 4/3 is equal to plus or minus the square root of 7 over 3 when I simplify the square root of 9. And then I just need to move my 4/3 to the other side. So I get t is equal to negative 4/3 plus or minus the square root of 7 over 3. And we just leave it like that. Okay? All right, so there's 2 on the next page for you to try. Go ahead and pause the video so that you can work those out. And whenever you're ready to check yourself or if you get stuck, play it again and we'll go over them. All right, so let's go ahead and see how you did on these practice problems. The first one, we had to move 9 to the other side, which makes it a negative 9, and then there's no leading coefficient to divide off. So we go ahead and take half the middle term. Half of negative 8 gives us negative 4, so that's our shortcut value that we're going to square and add to both sides. When we add it to the left-hand side, that creates a perfect square trinomial, which we can use the shortcut to factor into our variable and our shortcut number. So we have an x and then a -4 as our shortcut number, quantity squared. On the right-hand side, when we add in our -4 squared, that gives us 16, plus the -9 that's there leaves us with 7. So we go ahead and take the square root of both sides and then move our -4 over. So we should have ended up with x is equal to 4 plus or minus the square root of 7, and that's as far as we go. We don't give decimal approximations, we just leave it like that. Okay, let's look at the next one. Number 2, we start by moving the 2 to the other side. It's negative, so when we move it to the right-hand side, it should become positive. Then we have to get rid of our leading coefficient because it has to be a 1. So we divide every term by 3, which leaves us with x squared plus 5/3 x equals 2/3. Now that we have just our x squared in our x term, and our x squared has a leading coefficient of 1, we can go ahead and start completing the square. So we take half of the middle term, so half of 5/3 gives us 6/3. This is the shortcut number that we're going to square and add to both sides. And then once we've squared it and we've added it to both sides, the left-hand side, we can use our shortcut to know that this is going to factor into our variable and our shortcut number, which was positive 5, 6. Okay, so x plus 5, 6 squared is equal to, on this side, I have the 2/3 that was already there. And when I square 5, 6, I get 25/36. And then I need to get a common denominator, which would be 36. So I multiply 2/3 on top and bottom by 12. So that becomes 24/36. And then I can combine the tops to get 49/36. Now the cool thing about this one is when we take the square root of both sides, 49 and 36 are both perfect squares. So that's something that should simplify nice and give me an actual number I can work with, right? Don't forget your plus or minus. So we have x plus 5, 6 is equal to plus or minus 7, 6. And then when we move our 5, 6 to the other side by subtracting, notice what we have now are 2 regular numbers that we can combine like terms, right? So -5, 6 plus 7, 6 gives me 2, 6. And -5, 6 minus 7, 6 gives me -12, 6. And then I just reduce each piece. So I get a positive third or -2, okay? If I went through that really fast, go ahead and feel free to go back, pause the video, spend some time looking at it, because this is something we'll see again and again. But we want to go ahead and move on in the video, and I want to show you just a couple of word problems. Now, these word problems are the type of problems that you could use any of the solving techniques on. You could use quadratic formula, you could factor them, you could use completing the square, whichever one works best for you. Most of the time with word problems, unless they're really little numbers, I'm going to use quadratic formula just because it's a quick and easy way to get the correct answer without having to work with big obnoxious numbers, right? Okay, so let's go ahead and look at this first application problem. It says the rectangular frame on a picture is 8 inches by 10 inches outside and is of uniform width. So you can see here it's labeled 8 inches by 10 inches, and what they're saying is this width of the frame is the same all the way around, right? All right, what is the width of the frame if 48 inches squared of the picture shows? So 48 inches squared, anytime you see something squared, we should be thinking area, because we do a dimension times a dimension to get dimension squared. Okay, so this is talking about the area. So the area of the picture showing is 48 inches squared. So 40, oh, I can hardly write in here. Ah, it's not letting me write on top of there. Let's try a different pen. 48, oh my gosh. I don't know if you can see that or not. So 48 inches squared is all this inside here, right? That's what we're talking about. So we don't want to do 8 times 10, right? Because that would include the whole frame. We just want this distance right here, right? Times this distance right here. So we have to figure out how we can write those distances. So this distance and this distance is not including the frame, right? Now we don't know how wide this frame is. We just know that it's the same width all the way around. So I'm just going to call this x. We're going to say that's about a width of x. So if this is a width of x, then on this side, this is also a width of x, right? So if I want to figure out how long just this little piece right here is that doesn't include the frame, I can take the total length of it, which is 10, right? And I could subtract off the frame width and also subtract off this frame width, and that should leave me with just this line. So just this line I could write as 10 minus 2x. Does that make sense? Because the whole distance is 10, and if I subtract off the frame distance here and the frame distance here, then I'm left with just this picture showing distance. Okay? And then I want to do the same thing on this side, right? If this whole length is 8, and I want to take off the frame distance, which again is x, and the frame distance here, which is x, then I would take the whole distance 8 and subtract off this x and subtract off this x, so that I know that this end would end up being 8 minus 2x, right? So we have the length of this side, which is 10 minus 2x. We have the length of this side of the picture, which is 8 minus 2x, and we know that the area is 48. So remember, area is equal to length times width. So we take our area, which is 48, and we multiply the length and the width of our actual picture, which is 8 minus 2x times 10 minus 2x. And now this is something we should be able to work out and solve for x. Now we can't just solve each one equal to 48, right? That's not a thing. That's only a thing if it's equal to 0. So we're going to have to FOIL or distribute this all out so that we can move that 48 and get everything on one side so that it's equal to 0. So I'm going to go ahead and start distributing this. So 8 times 10 is 80. 8 times negative 2x is negative 16x. Negative 2x times 10 is negative 20x. And negative 2x times negative 2x is positive 4x squared. Okay, so a couple things I need to do to get this into standard form. I need to subtract this 48 to the other side so that it's equal to 0, right? And I also need to combine my like terms. So 80 minus 48 is going to leave me with 32. Negative 16 and negative 20 gives me negative 36x, and then I have my positive 4x squared. Okay, so this is all simplified, but it's kind of written in a weird order, right? We normally like to write our leading term first, then our x, then our constant, and we like it equal to 0 on the right-hand side. So I'm just going to flip it around so it's looks how we're used to having it. So my 4x squared I'm going to write first, then my negative 36x, then my positive 32, and it's equal to 0. Okay. Now, from here, you could try to factor it, right? Or you could do quadratic formula. This one has big numbers, but I notice that they're all divisible by 4. So if you wanted to take a greatest common factor off and do some product, that's totally fine on this one. So let's do that. If we take off a 4, we're left with x squared minus 9x plus 8 is equal to 0. And then we want to do some product with what we have inside here. Okay, so to do some product in here, this means I have a sum of negative 9 and a product of 8. What can I multiply to get 8 that I can combine to get negative 9? Would have to be a negative 8 and a negative 1. And because my leading coefficient is a 1, I can use my shortcut, which tells me this factors into x minus 8 times x minus 1. And I bring my 4 down. Now in this case, when I'm solving, I don't have to set 4 equal to 0 because it doesn't have a variable. So this just means x minus 8 equals 0 or x minus 1 equals 0. I move my 8 over, which gives me x equals 8. I move my 1 over, which gives me x equals 1. So I'm getting 2 possible solutions that solve this equation, right? But if we go back up into our problem and see what it's asking us to solve, it wants us to find what is the width of the frame. Okay, so what we're looking for is this little width, this little frame distance here, right? So if I look at my 2 solutions, I got 8 or 1. Now they both could work, but we need to check. If my frame distance here is 8 inches, that means that this frame would be 8 inches. there'd be 8 inches on this side. So right there, that's 16 inches of frame when this whole distance should only be 10. So it's not possible to do that. Another way to check it is you could plug it into our picture distance, right? So our picture distance, I'm just going to say if x equaled 8, then this width right here, 10 minus 2x, or 10 times 2, or 10 minus 2 times 8, right? Just plugging in x equals 8 here, we get 10 minus 16, which is a -6. And it's not possible to have a negative width of a picture, okay? So again, we know that doesn't work, okay? And then we look at our other one. We have x equals 1, and that works, right? Because if this frame distance is a 1, and this frame distance is a 1, and the whole distance is 10, that's okay. Because if I subtract 2 inches off, that means 8 inches of picture is showing. So that one works out. Okay. Again, we could just go ahead and work it out and say if x equals 1, then, you know, this 10 minus 2 times 1 gives me 8, right? And then I could find this distance also. 8 minus 2 times 1, that's 8 minus 2 is 6. Right? So just plugging it in to make sure it makes sense. But our actual answer is the 1 because it asked what is the width of the frame. Now if it had asked what are the dimensions of the picture that's showing, then that would be these answers, right? Because we figured out what the frame distance was and we subtracted it off. Does that make sense? All right, let's look at one more and then I'll have you try a couple practice problems. So this next one, oh, let me try 2 more, then you'll have a practice problem. All right, this next one's talking about zoo dimensions. At the Glen Island Zoo, 100 meters of fencing was used to enclose a rectangular petting area of 1,750 meters squared. So I see this squared and it says area. So this is talking about area, and we know area is length times width, right? The other thing it says is 170 meters of fencing. So when we talk about fencing, fencing is perimeter, right? And perimeter is all sides added together. So if I look at this fencing problem, right, I notice I have a length here, I have a width here, and I have a width here. So my perimeter is going to be 2L plus 2W, okay? All right, and what it wants me to do is find the dimensions of the petting area. So we need to figure out our length and our width, right? So let's go ahead and write down what we know. We know that length times width equals 1750, and we also know that 2 times our length and 2 times our width gives us this perimeter, right? So 2L plus 2W is equal to 170. And then we also know that L times W gives us our area, which is 1750. Okay. Now, I could solve either one of these, but I need it to just have L's or just have W's. I can't solve it when there's 2 unknown things. So what I'm going to do is I'm going to take this equation and I'm going to see if I can solve it for just L or just W. Because if I can solve it for just L or just W, then I can use that and substitute it into our area formula, okay? So I'm going to solve this one, and again, it doesn't matter which one you solve it for. I'm going to solve it for L. Solve for L. Now you could solve it for W too. In this case, either one is equally easy or hard to solve for, right? So I'm just picking L. Now if I want to get L by itself, I need to move this 2W to the other side. So 2L is equal to 170 minus 2W, just moving that 2W term to the other side. And then to get L by itself, right, I just need to divide off the 2. So I'm going to divide everything by 2. So that means that L is equal to 85 minus W, okay, when I simplify. Now, the reason that I solved it for L is because now I know what L is, right? L is the same thing as 85 minus W. So I'm going to take that 85 minus W and plug it into my area equation, okay? So instead of writing an L, I'm going to write 85 minus W, times the W that's there is equal to 1750. And now this is an equation that just has W, so that's easier to solve for, right? Because I only have one unknown. So I'm going to go ahead and distribute the W. So 85W minus W squared is equal to 1750. And then we need to go ahead and get it all equal to 0, right? So I'm going to go ahead and move, it doesn't matter if you move the 1750 to this side or if you move both of these terms to the other side. I'm actually going to move the 85 and the W squared over to the right side because I like my leading term to be positive. So my 0 is going to end up on this side because I'm going to move my 85 and my W to the other side. So when I move my W squared over, it becomes a positive W squared. When I move my 85W over, it becomes a negative 85W, and then I already have that 1750 over there. Now, this is one that we should be able to factor, right? I could even use a shortcut, but I'd have to figure out what multiplies to 1750 that combines to 85, and that's probably a little bit bigger numbers than we're used to dealing with. So instead of factoring this one, I'm going to use the quadratic formula, okay? So the quadratic formula, just going to do a little solving thing here, okay? Quadratic formula says that we do negative b, or the opposite of our b, which is negative 85, plus or minus the square root of b squared, so negative 85 squared, minus 4 times our a, which is 1, times our c, which is 1750, and that is all over 2 times our a, which is 1. So I'm going to go ahead and just keep simplifying. So this becomes a positive 85 plus or minus the square root. Negative 85 squared gives me 7,225. And then when I multiply these next three numbers together, I only have one negative sign. So it should turn out negative. And 4 times 1 times 1750 gives us 7,000 all over 2. And then again, we keep simplifying, so we get 85 plus or minus the square root of 225 all over 2. And this is good because 225 is a perfect square. So this gives us W is equal to 85 plus or minus 15 all over 2, right? And then we just work out the two options. So this is going to give us two answers. So we do 85 plus 15 over 2. And 85 minus 15 over 2. So 85 plus 15 is what? 100 over 2. And 85 minus 15 gives me what? 70 over 2. And then we just reduce each piece. So this becomes 50. And this one becomes 35, right? So now remember, both of these were answers we were getting for W, right? So they're saying the width could either be 30 or the width could be 35. So we need to know the length, right? We wanted to know the length and the width. And we found up here, remember, that the length is the same thing as 85 minus W. So if I were to find the length, and we do 85 minus whatever we get for W, then we should get two different answers here, right? So the width, if it's 50, if I plug 50 in here, 85 minus 50 leaves me with 35, right? So that means that my width is 50 and my length would be 35. And we just label them. Here we're talking about meters. Meters. Okay? So that's the dimensions there. And then notice over here, if my width is 35, then to find my length, again, I just do 85 minus that. So if I do 85 minus 35, that gives me 50. So I end up with 50. So notice in this case, it doesn't really matter how we label the length or the width, right? Because either the width is going to be 50 and our length is 35, or our length is going to be 35 and our width is going to be 50. So in my math lab on problems like this, it should just say, when it says find the dimensions, it'll have you put them in a box separated by a comma. Okay. So in this case, we don't have to say this one's the width and this was the length, or this one's the width and this one's the length. Either way, it's going to be 50 and 35. Okay. All right, let me show you one more. This one, we're finding numbers. It says one number is 6 less than the other number. The product of the numbers is 72. Find the numbers. Okay. Now, it doesn't specify if our numbers are positive or negative, so it could be that we get more than one answer and more than one pairing of numbers that satisfies this. Okay. So all we know is the product. Product means we're multiplying, right? So we multiply our two numbers. Let's just call our numbers x and y. So if we do x times y, we get 72, right? But then it also says one number is 6 less than the other number, right? So one number, let's say x, is 6 less than another. So that one's y. So how do I write that x is 6 less than y? Well, we could write that as x is equal to 6 less than y means we're doing y minus 6, right? So now, just like this last one, we can take what we know x to be, which is y minus 6, and we can plug it in for x in our multiplication statement. So this means that y minus 6 times y equals 72. And now this is something we should be able to simplify, right? So this gives us y squared minus 6y equals 72. Then I move our 72 to the other side. So y squared minus 6y minus 72 equals 0. And then I can do sum product. My sum is negative 6 and my product is negative 72. So 72 multiplies to 72 combines to 6 would be what? 12 and 6. So negative 12, positive 6. And because our leading coefficient is a 1, we can use our shortcut, which says that this factors into y minus 12 and y plus 6. And then we just have to solve each piece. So if I set y minus 12 equal to 0, I'm going to get y equals 12. If I set y plus 6 equal to 0, I'll have to move the 6 over, and I'll get y equals negative 6. Okay. Now these were just solving for the y number. So we have to figure out, if this is my y number, what's my x number, right? So if y equals 12, right, we have to plug back in for what x is. If y equals 12, then x equals 12 minus 6, right? Just plugging it back in. 12 minus 6, which means x equals 6. So here's one pairing, right? If y equals 12, then x equals 6. Then we have to check our second pairing. If y equals negative 6, then x is equal to negative 6 minus 6. Again, just plugging it into what we know x to be. So that means that x is equal to negative 12. So here we have two possible pairings that work out, right? Because notice 12 and 6 are 6 units apart, and they multiply to give us 72. Same thing here. Negative 6 and negative 12 are 6 units apart and also multiply to give us a positive 72. All right, so that is the end of the lecture for this section. You have 2 problems to try. So go ahead and pause the video and work on those 2 problems if you get stuck, or if you're ready to check yourself, unpause the video and we'll go over them. Okay, let's go ahead and look at the first practice problem. The first one says an open box is made from a 10 by 20 centimeter piece of tin by cutting a little square from each corner and then folding it up so that we end up with a box, right? The area of the resulting box, meaning the length of the box times the width of the box, once it's made, so we're just talking about this base piece, is 96 centimeters squared. So what is the length of the sides of the squares? So they gave us all this information, and they're asking us to find the length of the sides of the squares that we're removing here. Okay, so notice we have to cut out these little boxes in order to be able to fold this up and make a box, right? So I don't know how long this little box is, so I'm just labeling that X, right? But it says we're cutting the same size square from each corner. So I know all these little dimensions are X. So if I know this whole side is 10 before I've cut anything out, then if I take that 10 and I cut out a little X piece here and a little X piece here, now that side is going to be 10 minus the 2 X pieces that I cut out. Okay. Same thing with our width. If the width was 20 to start out with, and I'm cutting off a little X piece here and I'm cutting off a little X piece here, now my width is going to be 20 minus the 2 little X pieces that I cut out. Okay. So now I know the length and the width of my box, and we know that the area of the base of my box is 96. So area equals length times width. So 96 is equal to my length times my width, right? So again, in order to solve this, I need everything on one side so it's equal to 0. So we FOIL out the two quantities and move our 96 over. And then I rewrote it just so that it looks like the standard form we're used to seeing, okay? So you should end up with 4x squared minus 60x plus 104. And then from here you can factor it, or you can use the quadratic formula. So I wrote both ways down, okay? So if you did quadratic formula, you can check yourself here. If you factored it, you can take out a 4 and then do sum product. Either way, you get the same two answers. So the two answers that we get is 13 or 2. Okay, so once we have those two answers, we have to see which one makes sense. So I'm going to go back up for just a second. Remember, it was saying, what is the length of the sides of the squares, meaning these little squares that we're cutting out. So we're trying to figure out what is that little X distance. Okay, so the two answers that we got here down below is that it's either 13 or it's 2. So there's two ways to check yourself. You can just do it in your head, right? If it's 13, if that little square is 13 and this little square is 13, well, that's 26 already. And this whole side's only supposed to be 20. So 13 doesn't work, right? Or you could take 13 and just plug it in to one of these distances to make sure it's positive. If we plug 13 in, you can see here we get a negative length. So that doesn't work. So we know 13 is not how much we're cutting out of those little side squares. So that means our answer has to be 2. Now I actually went ahead and plugged it in and made sure that when I plug it into our width, we got a positive, and we plug it into our length, we got a positive. But it didn't ask me for the actual dimensions, so this is really not my answer. The only thing it asked me for is what is the distance of that little square we were cutting out. So my answer is actually just 2 centimeters, because that's how much we're cutting off of each end here in order to create this box. Okay. All right, let's look at the last one. The last one says we're finding the dimensions of a rectangular Persian rug whose perimeter is 28 feet and whose area is 48. So we should be able to make a perimeter equation, because perimeter is 2 lengths plus 2 widths. And we should also be able to make an area equation, which is length times width. Okay. Now, we are not given length or width, so I'm going to go ahead and use my perimeter equation, which we're setting equal to 28 because that's what it said the perimeter was, and I'm going to solve for either L or W. It doesn't matter which one you solve for. I chose L. If you chose W, that's okay. You'll get the same answer. So I went ahead and solved it for L by moving my 2W term to the other side and then dividing off my 2. So that tells me that L is equal to 14 minus W. So now that I know what L is, I can plug that in for L in my area equation. So my area equation is that my area 48 is equal to my length times my width. So that means 48 is equal to, instead of writing L, I'm going to write in 14 minus W, because that's what we figured out L is, times my width. And then from here, you can go ahead and multiply this out and move everything to one side so that it's equal to 0. And once you get to this step, you can either do sum product or quadratic formula. Okay, I did sum product because it's a small enough number. We should be able to figure out the pairing, which would be -6 and 8. So when we solve those, we get a +8 or a +6. Okay, and then we check both of our answers. If our width happens to be 6, remember we can find our length by just plugging it back in here. So whatever we get for our width, we just do 14 minus that value to figure out our length. So when our width is 6, our length is 14 minus W, so 14 minus 6, which gives us 8. So when our width is 6, our length is 8. And then when I check 8, right, when I plug 8 in, 14 minus 8 is 6. So it doesn't matter if we label our width as 6, then our length is 8, or our width is 8 and our length is 6. Either way, the dimensions of this rug are going to be a 6-foot by 8-foot rug. Okay. All right, so that is the end of section 3.2b. So you should now be able to do the assignment in my math lab for that. If you have any questions or any problems, please let me know.